Hey guys, this is Mrs. Harbin, and this is Algebra 1, Section 6.3. Let's start with a quick lesson opener and solve for y. Remember, when we are solving for a variable, we want to undo everything that's been done to it and get it so that the variable is all by itself. So on the left-hand side here, right now, it's having 2b added to it, so we need to go ahead and subtract 2b. Because this is an equation, it does need to stay balanced, so we need to do the same thing to both sides. And we get y equals a minus 2b. On the right-hand equation here, has 10 being added to it, and then it's also being multiplied by 2. So the first thing we want to do is get rid of the 10. So let's subtract 10 from both sides to get 2y equals 6m minus 10. And now we have to divide by 2. But whatever we do to the left side, we have to do to everything on the right side. So this gets divided by 2, and this gets divided by 2. And we end up with y equals 3m minus 5. All right, go ahead and try to solve these for y on your own, and then pause the video, do your work, and check your work. On the left, we'll subtract 4z from both sides, which gives us negative y equals x plus 6z. And then if we multiply everything by negative 1, all right, you can also divide by negative 1 as well. Either way, you get y equals negative x minus 6z. All right, on the right-hand side, we want to subtract 5x. We get negative 2y equals negative 5x plus 10. We can go ahead and divide everything by negative 2. And when we do that, we get y equals positive 5 halves x minus 5. Negative 5 divided by negative 2 is positive 5 over 2. And 10 divided by negative 2 is negative 5. Our life application for this unit is that the student will see that representing information in multiple forms should maintain the integrity of the information. Speaking God's written word should be matched with an illustration of God's word in action. Whatever we do and whatever we say, those two things need to match the action. When we're representing data, we need to make sure that we're accurately representing the data, and we're not just making up graphs or making up information. If we're using this information to help others and to make predictions about weather and safety or other things, we need to make sure that we're giving correct and accurate information. So make sure your walk matches your talk. Make sure your work matches the data. Our lesson objective for today is that you, the student, will write linear equations in slope-intercept form and identify the slope and y-intercepts of a linear equation. Remember, a linear equation is just a straight line. No curves, no anything else, just a straight line. It's either going to be positive, negative, zero slope, or undefined, according to our little Mr. Slope face picture there to help us remember that. Slope-intercept form of a linear equation is y equals mx plus b. M, we already know, is the slope of our line. That's our rate of change, or how steep a line is. And b is going to be our y-intercept. That's going to be the one place where it crosses the y-axis. It might be here, it might be here, but this value b is going to represent that one y-intercept. Linear equations only have one y-intercept. To write 3x plus 2y equals 6 in slope-intercept form, the first thing we're going to do is solve for y. So we'll subtract 3x from both sides and get 2y equals negative 3x plus 6, or 6 minus 3x. We then divide everything by 2. We get y equals 3 minus 3 halves x. Most of the time you'll see that flipped around so that our x term comes first. So we can rewrite that as y equals negative 3 halves x plus 3. We now know our slope. That's the coefficient or number in front of x. Negative 3 halves, and we know our y-intercept. That's the number down here, the constant term, 3. So we just said our slope is negative 3 halves, and our y-intercept is 3. There are several forms of linear equations. The first is standard form. In standard form, our x and our y are on the same side. X comes first before y, just like in alphabetical order. Our constant term is by itself on the other side of the equation. And we have no fractions. Our coefficients are not fractions. And our first coefficient is positive. So x and y on the same side, no fractions, and our leading coefficient is positive. Slope-intercept form, y equals mx plus b, takes the same information but puts it in a different form. We now have the slope identified and the y-intercept identified. Function form just changes our y to f of x. F of x equals negative 3/2 x plus 3. The slope-intercept form of a line can be used to quickly graph the line. First, by plotting the y-intercept. Then we use our slope to plot one or more other points by counting up or down and left or right to plot other points. We then connect our dots. So let's try this. Graph y equals 1/2 x plus 4. The first thing that we're going to do is plot our y-intercept, which is 4. We'll then count our slope, which is 1/2. So we can go up 1 and to the right 2 and plot a point right there. Or we can also go down 1 and left 2, because negative 1 divided by negative 2 is also a positive 1/2 slope. So we can go down 1, left 2. We know from our positive slope here that our line should look like this, because positive slopes go uphill. So if we connect those dots with a straight edge, I'm doing it freehand, but connecting those dots with a straight edge, we do get a line that looks like this. I'm going to advance through the slides here and draw a line through our points. There we go. Let's go ahead and write 2x plus 3y equals negative 3, that's standard form, as a linear function. The first thing we want to do is solve for y. So we'll subtract 2x from both sides and get 3y equals negative 2x minus 3. We then do have to divide everything by 3 to get the y by itself. Y equals negative 2/3 x minus 1. And then we're going to swap out our y for f of x. F of x equals negative 2/3 x minus 1. Let's go ahead and write y equals 3 in slope-intercept form. When y equals 3, we know that we have a horizontal line and our slope is 0. So we would have y equals 0x plus 3. The y-intercept is 3 and the slope is 0. How would we graph y equals 0x plus 3? Well, you just saw me graph a quick sketch of that, but we would plot our intercept at 3. We know our slope is 0, so we're not going to go up or down. And so we're just going to draw a straight line. Y equals 3. At every value of x, y equals 3. When x is 1, y equals 3. When x is 2, y equals 3. When x is 3, y equals 3. So y equals 3, regardless of our x values. In function form, we would say f of x equals 3. No matter what our x is, y is equal to 3. This is called a constant function. Constant means it stays the same. It is constantly 3. So y equals a number is a constant function. Today, we wrote linear equations in slope-intercept form, y equals mx plus b, using our information about slopes and intercepts. We also identified the slope and y-intercepts of a linear equation. Make sure that if you have any questions, you write those down, and we will do some practice problems next class.